Hello class, today we're going to do another lab. Okay, over the next 2 days we're going to investigate exponent rules. There are several exponent properties that we have to be familiar with. So in this lab what you're going to be doing is you're going to be typing problems into the calculator and recording your response. And then what's going to happen, what I want you to do is I want you to look at the patterns that you see and then write a sentence about what's going on in that property. So let me explain. So here's our data sheet that you're going to use, okay? And it's going to be a good idea if you can print this. Okay, so, do the best that you can, please, okay? So the first one, it says, use this sheet for data collection. It will also serve as notes for future reference. For rule number 1, give factors and evaluate. I'll explain that in a minute. For rules 2, 3, and 4, just evaluate. So first off, let's talk about 3 to the 7th power. What are we talking about when we do that? So what is the 3 called? Okay, the 3 is called a base. It's called a base. That's what that number at the bottom is called. The 7 is called the exponent. So in this lab, what you're going to be looking at is some problems like that. But when you're dealing with the properties, you're going to look at a more generic way of looking at it. So you're going to look at it the algebraic way. So we look at it as a to the nth power, okay, where the a is still the base and the n is still the exponent. But each of those, I can plug in any number, okay? So what numbers do a and n stand for? So in the previous example, the a stands for the 3, and the n stands for the 7. Okay, so like I said, the a and the n are just variables. So it's called a generic form. So let's look at this first rule. So in the first rule, it says 5 to the 3rd power. And then I asked you to write the factors out. Well, the factors are, what does 5 to the 3rd power mean? Well, 5 to the 3rd power really means 5 times 5 times 5. Those are called the factors of this problem. Now, there's 2 ways that you can evaluate this. Evaluate means get an answer, simplify. Okay, so you can type this into the calculator as 5 times 5 times 5 using the factors, or you can use the exponent key. The exponent key is the caret key that looks like this right here. Okay, and I don't know that I can't show you what it looks like, but it's over here, right there, the one that I'm kind of pressing on top of right there. So that is the exponent key that we're looking for, okay? So that's what I want you to use to do your exponents. Okay, so let me clear this out. Okay, so how would we use that then? You would type it in as 5 caret, and we call it a caret key or exponent, and you'll notice on the calculator it put it up above, kind of shifted it up. And we've done that before, and we talk about how many 5s there are. There's 3 of them, so that's 5 to the 3rd power. And any way you look at it, you end up with 125 as your answer. So then you're going to do the same thing to the next one. 4 to the 6th power, write out the factors, and give me an evaluation. 7 to the 2nd, 2 to the 4th, and so on. And then what I want you to do is I want you to look at all of the factors and all of the evaluations and see if you can determine a sentence right here to tell me what that a to the nth power means. What does that mean that we're going to do if you have a problem in that format? Now for rule number 2, you'll notice that each one of those are to the 0th power. So you'll type in the same thing, but this time you'll notice I'm not looking for any factors, I'm just looking for an evaluation. Okay, so all I want you to do is type it in, get an answer. Type it in, get an answer. And then see if you can write a sentence about what a to the 0th means. The next one, notice that all of these are to the 1st power. Okay, so type in 6 to the 1st power, come up with an answer, and so on and so forth. And then come up with a conclusion. That's your sentence that I want you to do. How would I do any problem that is a number to the 1st power? Okay, and then we come to this next one, rule number 4, and this is where it really begins to be a little difficult. Okay, so you'll notice in this particular one right here that we have a problem of 2 to the negative 4th. So how do I type in a negative exponent? The same exact way that you would type in any other exponent. You would do 2, exponent key, negative 4, remembering the negative is a different key than the minus, and you hit enter, and you'll write down what it gives you. So in this particular case, it gives you 0.0625. And you'll do that all the way down. Okay, when you get down to this one, okay, what you're going to do is you'll type in 1 divided by 6 exponent negative 4. You type it in exactly the way you see it, and then you hit the enter key. Okay, so that's what we're looking for. So I want you to do all the problems on the left side here, and then turn around and do all the problems on the right-hand side. And I want you to notice the answers on the left and the answers on the right. Do you see any commonality in them? So in this particular one, I'm going to have you do 2 conclusions. What happens when you have just a to the negative nth? And what happens if I have 1 over a to the negative nth? Kind of like these problems. So basically, we're looking at examples of this and examples of this. What happens when you have a problem like that? How do we work them? Okay, rule number 5. Now, in this one, it gives you an evaluation and also gives you a 1 exponent expression. Well, evaluation, we know, means get an answer. Okay, get an answer. Well, what I want to know on the 1 exponent expression is, if I were to take this expression right here and rewrite it so that I only have 1 base of that same base, what would my exponent be? If I have 1 base, what would my exponent be so that this answer and this answer are the same? So that's what I'm looking for, okay? So then I want you to write a generic statement. What happens if I have a base with an exponent and the same base with another exponent, or with another exponent? What could I do to simplify that statement? Okay. Then for rule number 6, you're going to do the same exact thing. Okay, you're going to evaluate it, and then using the base, I would like for you to write it with 1 exponent. Now we need to remember, when we're writing exponents like we've done before, you're not allowed to have negative exponents. Okay, so that's going to be kind of interesting, okay, whenever you're doing those. Okay, so hopefully you remember what happens. Okay, because the negative exponents, we talked about right here. There's negative exponents. So what happens there? Would I get negative exponents? And then would a second rule apply? So that's what we're looking for on that. Okay, then rule number 7. What happens if you have an exponent raised to an exponent? So you'll type this one in exactly the way it's written. So you'll type in parenthesis 3 exponent 5, okay, and then hit the right arrow key to get out of that, and to get out of that parenthesis, so hit the right arrow key again like that, and then hit the exponent key again, and hit the other exponent. So that's what we're looking for, 3 to the 5th to the 2nd. Okay, make sure you get those parentheses and make sure you get it written like that. And then you would hit the enter key. Okay, that's going to give you an evaluation. That's going to give you this answer. And then what I want you to do is, again, write a 1 exponent expression. So if I have that same base, what exponent would I put there to get the same answer there and there to get the same answer? Okay, then do the same thing on rule number 8. Okay, rule number 8 here is, what if I have different bases, but my exponent is the same? So again, you're going to type that into the calculator, 3 to the 2nd power times 4 to the 2nd power. But be very careful when you're doing that. 3 exponent 2, when you're that way right now, there, you've got to make sure that you get out of that exponent in order to type in the times. So now, times, let me get rid of that one there. Okay, so we got times, and then 4 exponent 2. Now, at that point, you could hit the enter key, and you'd get an answer. Okay, so what happens? Write down an answer, and then what could I do for a 1 exponent expression? What base would go here to have the same exponent of 2 for this answer and this answer to be the same? So that's what I'm looking for on this particular lab activity. So all you're going to do is you're going to be typing problems into the calculator, and I want you to come up with some kind of a sentence that explains the rule that's going on. Okay, now tomorrow we'll actually go over this lab and kind of look at some of those things so you'll understand what I'm looking for on all these statements here, like what's happening. And then we're going to have an assignment that we're going to do together. And then you'll have an assignment that you'll do by yourself. And that one's going to be the one for a grade. Okay? So all I want you to do today is punch some buttons on the calculator and evaluate each of these problems. Okay, exactly the way I explained through this video. And then attempt to write some kind of a conclusion statement about that particular property. So until tomorrow, when we talk about this again, I'll see you later.